Okay. Hey, Maddie, Payson. All right, number 12. Let's start with that one. So we have to take the derivative, right? And to Maddie, and to do that, we have to use the quotient rule, right? Okay. So who's got that? Okay. Go. Low d high. So low is x squared plus 3. D high is 2x. Minus high is x squared. Uh-oh, Elena. Times d low is 2x. You did do it right. Okay. All over the square of what's below. Okay. Is there anyone in here who cannot find that derivative on their own and wants me to go through that a little bit more? Okay. No, because this subtraction screws things up. Okay, if you can only cancel if it's all multiplication. So from here, what I'm going to do is simplify it a little bit. If I distribute this 2x, I get 2x cubed plus 6x, and then if I combine those, I get minus 2x cubed, and that is all over x squared plus 3 squared, right? How am I doing so far? Okay, then this is really handy. Yeah, these will cancel. So then I have 6x over x squared plus 3 squared. So yeah, you're right. Okay, so now we have to take that and set it equal to 0. So 6x over x squared plus 3 squared equals 0. The bottom will never be 0, right? So we just don't even worry about that. Okay? Because x squared is always going to be positive, so it'll never cancel with a positive 3. So really all I'm solving is 6x equals 0, which means x equals 0. So yes, that is our only candidate for a maximum or a minimum. Okay? All right, pick a number. 1, plug it into what? The derivative. Okay? So if I plug that into the derivative, the top is going to be positive, the bottom is going to be positive, so the whole thing is going to be positive, which means the other side is going to be negative. Shade in an I unless it's a double 0, yeah. So if this had been 6x squared instead of just 6x, then it would be the same on both sides, yeah. And I mean, you could see that because then if I plugged in 1, I would get positive over positive. But if I plugged in negative 1 squared would be positive, right? It would still be positive over positive. So that's why that happens. So I don't really know what they're actually asking you. What does part A say? Okay, so it is increasing from 0 to infinity, and it's decreasing from negative infinity to 0. And then we can use the first derivative test to recognize it since it's decreasing and then increasing. That means that 0 is a local minimum. Because the fact that this is negative means it's going down, and then it comes back up. So the 0 is at the bottom. Okay? Okay. Probably with shade. All right, so let's do a little trig. Tegan, can you take the derivative of that for me? Awesome. Okay, everybody get that? Derivative of sine is cosine, derivative of cosine is negative sine. Oh, Maggie, what do I do now? Okay, so cosine of x minus sine of x equals 0. How do I solve that? Yeah, if you add sine x to both sides, then you get cosine of x equals sine of x. Okay? Okay? No. Cosine of 0 is 1, sine of 0 is 0. You do normally. Yeah, but in this case, yeah, there's nothing we can do about that. Okay. Right. So one place where this happens is in a 45, 45, 90 because cosine is adjacent over hypotenuse and sine is opposite over hypotenuse. So if the adjacent and the opposite are both the same, then that means the sine and the cosine are also going to be the same. Okay? So that's a 45-degree angle, but we're in calculus class, so we always want our answers in radians. So that's pi over 4. Good. Okay, then what, Payson? What quadrant? Quadrant 3. Good, because if I go to quadrant 3, then this is -1 and this is also -1. So opposite over hypotenuse and adjacent over hypotenuse also work out to be the same. So how many radians is that? 180 plus 45, 225. Then we got to change the 5 pi over 4. Halfway around is pi, and then another pi over 4 is 5 pi over 4. Okay? All right, so I'm only going from 0 to 2 pi this time. One of my zeros is pi over 4. Another one is 5 pi over 4. Pick a number. Hold on, hold on, hold on, hold on. Katie, pick a number. Pi. Okay. What is the cosine of pi? -1. What's the sine of pi? Sine of pi is 0. So is it going to be positive or negative? Okay, so it's negative in this region, which means it's positive on both sides, which means you guys can now answer A and B on your own. All right, number 14. Okay, so this is a tricky derivative to take. Hero, what's the derivative of cosine squared? You could do it using the product rule, yep. So let's think of it as cosine times cosine. So the product rule is the first one times the derivative of the second one, okay, plus the second one times the derivative of the first, right? Okay, so yes, right, so since those are both the same, we'll combine those in a minute to -2 cosine x sine x, which is what you got. Mason did the chain rule instead. He put the exponent, he put the exponent in front, made it 2 cosine of x, and then multiplied it by the derivative of cosine, which is negative sine. So you get to the same place there, okay? Okay, and then Hero, what's the derivative of -2 sine x? Okay, awesome. So like I said, we can combine these to -2 cosine x sine x. This is just plain old -2 cosine x. Set that equal to 0. All right, let's solve a trig equation. Everybody's favorite. Woohoo, Elena. Any bright ideas? What kind of? I don't really want to do that this time, and I know that's really inconsistent because last time I did that and Maggie was like, wait, why'd you do that? And now I'm like, no, we're not going to do that anymore. Is there something I can factor out of those things? Okay, and I'm even going to go -2 cosine just to make things a little bit more special. So if I factor -2 cosine out of this, that'll leave me sine of x. And if I factor -2 cosine out of this, that leaves me +1. And that equals 0. Because anybody want that? Because then a negative times a positive will give me a negative, which is what I want. Then that makes it good. Yeah, exactly. All right. So now we've got two things that multiply together to equal 0. So that means the individual pieces need to equal 0. Okay. So that's why factoring is fun. Why would I give Gage a point? Yeah. Okay. What's wrong with that is that you lose the solution. No. You can never divide by a variable. Okay? Because you lose part of the equation when you do that. So you do get this piece right here doing it that way. You get sine of x is equal to -1. Okay? But then you totally miss out on this part over there because you divided by that, so it just canceled and went away. Okay? How do I solve that for? Yeah, just get rid of that. So cosine equals 0. Okay, so where does cosine equal 0, Mason? Let's go to Hero's favorite. She loves the unit circle. Yeah, it's on the x-axis. Oh, no, I'm sorry. It's on the y-axis. Yeah, because it's where x equals 0. Cosine is the x-coordinate on the unit circle. So it's where x equals 0. So that would be pi over 2 and 3 pi over 2. Okay. How about the other one? Sine equals -1, Maddie. Sine is the y-coordinate on the unit circle. So where does the y-coordinate equal -1? No, at 0 the y-coordinate is 0. At pi the y-coordinate is also 0. Okay, no, remember sine is the y-coordinate, okay? So we want the y-coordinate to equal -1. You named where the x-coordinate was -1. Where's the y-coordinate -1? The y-coordinates of which of these points is -1? This one, this one, this one, or this one? I am too. What's the y-coordinate of this point? 0. So that's not what we're looking for. We want the y-coordinate to be -1. What's the y-coordinate of this point? Don't want that one either. What's the y-coordinate of this one? Throw it out. What's the y-coordinate of this one? Aha. So this is the one that we're looking for. How many radians is that? 3 pi over 2. It's 1 pi and then another half pi. Okay? But we already had that one. Okay? Does that make it a double 0? Yes. Are we in the Shaden situation? Yes. I guess so. No, 2. Pi over 2. Oh, yes, there's only one solution for sine of x equals -1. If you think about the graph, and there's -1, it's only one place, yeah. All right, so those are our zeros. pick a number that's not one of those numbers. Payson. Now we're going to remember that this is a double zero right here. Yeah. Yeah, it's pretty hard to plug 1 into cosine. We don't know what the cosine of 1 is. No. We know what the cosine of... that's pi over 4. Okay. Let's do pi over 4. So if I plug pi over 4 into here, really all we need to know is the cosine of pi over 4 going to be positive or negative. Positive, because it's in the first quadrant. Okay. So if I go positive times a negative 2, then this is going to be negative. Okay. Then the sign of pi over 4, is that positive or negative? That's positive. So if I take a positive and add 1 onto that, it's going to also be a positive. So a negative times a positive is a negative. So pi over 4, which is in this area right here, is going to be negative. Okay. Then it alternates here. Pi would be positive because this is 0 plus 1, which is 1. Then this is, cosine of pi is negative 1. So that'll make that be positive. Yeah. Well, here's pi, and cosine is the x-coordinate, which is negative 1. Yep, cosine's x, sine is y on the unit circle. Okay? Because adjacent, right, is going to be, like you said, on the x-axis, and opposite is on the y-axis. You want me to start drawing some Ferris wheels, and we can go back to... okay, and then since this is a double root right here, it's not going to alternate. It's going to be increasing on both sides, okay? So now you guys can fill out A and B on that. It's increasing from pi over 2 to pi, decreasing from 0 to pi over 2. This is a maximum or minimum? That's pi over 2 is a minimum, so it's going down and then back up. What about 3 pi over 2? Neither one. Neither one. Yeah, it's going up, and then it levels out, and then it goes up some more. Okay, so we guys fill that out. We have to do all the rest now. We've just been doing the first derivative test. I mean, who even knows, right? Yeah, I was wondering about that, if that really counts as a double root. Yeah, that's what I have. To square the x, it would have to be, the squared would be inside the parentheses. All right, you want me to do what now? 15 through how many? Go! Oh, okay. Find the local maximum and minimum values of f. All right, this would be good practice for your quiz. How do I find the derivative? Okay, this makes me... no, we're not there yet. Okay, take the derivative. Now what? Set it equal to 0. You know what? In this case, I only have one term with an x in it, so I'm not going to factor it. I'm going to get that x by itself. If I have two terms with x in it, then I have to factor. Yes, x to the fourth equals 1, which means x equals what? Plus or minus 1, yeah. And I'm feeling like both of those are even roots again, and this shouldn't alternate, but now I'm lacking confidence because it didn't work out in the last one. So let's see what happens. So negative 1 and positive 1, pick a number, plug it into the derivative. Negative, so this would be negative, and then I feel like it wouldn't alternate. It wouldn't alternate because x to the fourth equals 1. That means 1 is a double root and negative 1 is a double root. Yeah, let's plug in another number. If you plug in 2, it's positive, huh? Okay. What do I know? All right, so the first derivative test, all you need to know, that's what we've been doing before. What's negative 1? Maximum, and positive 1 is minimum. Yeah. You plugged in 1/2. No, 1/2 to the fourth is, it's into the derivative, yeah. Right. Huh, very strange. I don't know what's going on in my life anymore. All right, 16, take the derivative. Gotta use the quotient rule. Go ahead and do it, Tegan. We're waiting. Okay, low. B high, don't need it. Minus. High. Love it. This will... Alrighty, so if I simplify this, I get x squared plus 4 minus 2x squared over... no, because there's subtractions in there. I can't. It's got to be factored. It's got to be times, and then I can cancel. Negative x squared plus 4. Right, and then in this case again, we're not going to worry about the bottom because that'll never be 0. So I just need negative x squared plus 4 to equal 0. So x equals 2 or negative 2. Pick a number, 0, positive or negative. And then it alternates on either side. So minimum, maximum. Don't want to do number 17. You guys need to hang on to your homework because we're gonna add on to it. We're gonna do the second derivative stuff tomorrow, and so you're gonna want to know what the first derivative was already to take the second derivative. Okay.